Good afternoon, everyone. Welcome to this lecture, and we are still in network layer. And in this lecture, we will be talking about the network address translation, which is called NAT. So, what is NAT? NAT is a technology that makes or allows a private network or private organization to use some or a block of private addresses internally. As you know, what is the private address? And even a set of global internet addresses for external communication. That means internally in the private network, we've got some private IP addresses, and each private IP address is being given to a specific computer or a host or whatever. And even corresponding to those private addresses, we will be having a set of global IP addresses for in order to communicate externally, communicate to another host which is outside this private network. And this can be done by mapping between the internal IP addresses or private IP addresses, which officially assign it to these to the external addresses. This can be done by the network address translator. In order to make difference between the addresses which is used inside a home or an organization, or as we can say the private addresses, and those which are global addresses or public addresses which are used for the internet, the Internet Authority have received three sets of addresses, private address. What do you mean by that? When you are inside your home or inside a specific organization and you are installing a LAN, or as other words, we can say those computers are connected to a hotspot or to a modem which has been given by an internet service provider. Those three private addresses are from 10,000 up to 10,255, and that one. So that means the total number of the addresses is going to be 2 to the power 24. And this range from that one to that one, and that range to that one. So, but mostly you can see in our computers when they are connected privately, we are using those IP addresses. So even they can be used as well. So these are called the private addresses which has been given by the internet authorities. So we can say those addresses which are in a private address, they are unique inside the organization. They are only belonging to that organization. So this is going to be inside this organization, and that one and that one. But the internet doesn't recognize those IP addresses. But even the router has a private address, but the router has a public address which transfers those the data inside them to the internet, but not directly. There may be something which is called NAT in order to send the data or receive data to those private IP addresses. So this private network use some private addresses. However, the router connects this network to the internet through a global IP address, which is this one, and a private IP address. So that means when this computer, which is inside this private address, wants to communicate with the internet, it goes to the router and it uses this IP address, and this one is uses this IP address. So when it's connecting externally, this global IP address is going to be used, and even for that one and that one. And even when the data is going to be received through the internet to that one, the internet doesn't recognize that IP address. It only recognizes this public IP address. So this public IP address recognizes that one and send the data through that one through by adopting some rules or stuff like that, which we are going to cover. So as this example, we have this private address. When the data goes to the internet, this is going to be the address, which is the private address, the address of the source. But when it goes to the router changes this IP address, which is a private, to that one, which is a global. So this one is going to be used in order to communicate with the internet, and vice versa. When the data comes from the internet to a specific one, to that one, this IP address is going to be used in order to specify the destination, which is that computer. But when it comes to inside the private network, this address is going to be translated to that one in order to recognize that particular IP address or particular host. So when the data goes out to the internet from a private network, the method is straightforward, and it's straightforward and it can be done easily. But when a NAT router knows the destination address for a packet coming from the internet. How does the NAT router knows that one, which specific address to send the data to? So there may be, hundreds of private IP addresses, and each one belonging to a specific host. That means inside the private network or inside an organization, we have some computers, and each one has its own private address. And this problem is going to be solved by NAT, Network Address Translation Router, which has a translation. So the translation table configuration in NAT router has three types. The first type is using one IP address. Look, we've got one IP address here. For each private IP address, we've got an external one, which is going to be the destination. So if this one wants to communicate with that destination, it comes to that one. So this one is going to be private, and that one is going to be the destination. So it uses the global IP address, which is that one, in order to communicate with that destination. And even if the data comes from this is going to be the source, so where this is going to be the internet, and the destination is going to be this one, not the private network, because we are connecting globally. So this is going to be the destination, and so if the source, the internet IP address is that one, the private network is going to be this one. So the data is going to be received by that one. So in this way, using one IP address, the communication must be initiated by the private network. The private network must start communicating with the global internet, and yeah, this mechanism describes requires that the private network start the communication. This is the same as the previous one, but in the other words. But that's the important part, which is the translation table, which has a private address and an external address. So using one IP address there is some restriction. That means only one source in the IP address can communicate with that destination. So this is a restriction here. In order to solve that, we can use the other type, or the other method, which is using a pool of IP addresses. So those IP addresses are going to be global. So if you have, for example, four private IP addresses, in this case, we can use four different public addresses or global addresses. So in this case, four private network hosts can communicate with the same external host using at the same time, because each pair of the address defines a connection. That means the first private address is going to use this one in order to communicate globally, and the second one uses that one, and the third one, and the fourth one as well. So the third method solves this issue as well. So in order to allow many-to-many relationship between the private network host and the external server, we need to have more information. What are those information? For example, suppose two hosts with IP addresses 172.18.3.1, and the other one wants to communicate with this server, okay, which is that one, this external address. So what happens? The private port and the external port are going to be used. So this port is used to that IP address, and that one is used to the other IP address, so they can simultaneously connect to the same host at the same time. Network address translation and internet service provider. So the internet service providers may use the network address translation in order to conserve the addresses. For example, suppose an IP is granted only 1,000 addresses but has 100,000 customers. So how can we do that? How can we distribute 1,000 addresses in order to cover those 100,000 of customers? Let's see in this figure. So this is the internet service provider. So each IP can equal to 100 IP addresses in the private address. That means we have 1,000 addresses, and each local area network, each organization has 100 private addresses. So that means 100 is going to be 1,000 100,000. And even when the private networks wants to communicate with the ISP, they are 100,000 IP addresses, but by using the NAT technology, they are going to be translated into 1,000 IP addresses, which is the coverage area of the internet service provider, because each IP address of those 1,000 IP addresses can cover 100 private IP addresses. And so far we have covered the IP version 4, but we have made so many solutions because of the lack of the number of the IP addresses in the IP version 4. We used we caused address depletion. That means we don't have enough global IP addresses to be given to each host inside a private network or public network. So despite of these all things, we have some problem in the IP version 4. That's why the IP version 6 has been implemented in order to cover more hosters or stuff like that. Because the IP version 6, version 4 uses 16 bits, while the IP version 6 uses 32 bits. This is the IP version 4. This is an example of it. Sorry, we uses 32 hexadecimal digits, which is going to be 128 bits long. And we can say even it is 16 bytes, because each 2 hexadecimal digit can be 16 bytes, and if you divide this one by 8, you'll get 16. So this is how to write down an IP address in version 6. So it divides into some sections, and each section is 2 bytes. Okay, each section is 2 bytes. So this FF is a byte, and that FF is a byte. So this is 2 bytes, 2 bytes, 2 bytes, 2 bytes. That means all of them together can be 16 bytes. So as we can see, the length of the IP version 6 is long, so we can abbreviate it. You can use some you can make it a bit shorter by doing some technology. So we can remove the zeros. For example, those 4 zeros together can be written only using 1 0. So when you see 1 0, that means there are 4 zeros in that section. And even we can remove the leading zeros, but we can't remove the trailing zeros. So this is going to be written as the same as it is, but this one is only 1 0, and that one as it is, and this one 1 0, that one 1 0, that one 1 0, and those leading zeros can be removed. So ZF74 is going to be used. And more abbreviated version is using a gap. That means we have that gap, and we see this section. That means we have how many sections? 1, 2, 3, 4, 5. That means that gap is 3 sections of zeros. So this is an example. Expand this address, which is written in IP version 6, to its original. So you can say that this is written as it is, 12, 13, so 4 hexadecimal digits. And this 12 is, it must be 4 hexadecimal digits, but it is 2. That means the leading zeros has been removed, so it's going to be 0, 0. And this one, 3 zeros has been removed. And this 15, 2 zeros has been removed. And this 0 can be translated into 4 zeros. Look, that gap there. How many sections do we have? 1, 2, 3, 4, 5. That means that gap is 3 sections of zeros. 1, 2, 3. This is how you can translate the IP addresses, the IP version 6 addresses, from abbreviated form to its original form.